Hello everyone, this is the option appraisal presentation of Group 28. In this project, our group was divided into 4 parts to improve the Glasgow transport system from different aspects. Okay, next I'm going to show you the first part, which is working on new guard network and cycling safety improvements. As you can see in the slide, compared to other cities, Glasgow's road occupancy is very high, up to 25%. Therefore, based on the current state, we want to build a super blocks model. In this model, there are more open space, safer cycling paths, and more efficient land use. Next, we use the SWOT to analyze the whole model. We listed its strengths, weaknesses, opportunities, and threats. Then, we rated large and small blocks according to key criteria. Finally, we found multiple small blocks are more suitable for this project. At the same time, considering the safety of cycling, we have formulated 4 plans to improve the safety factor. They are Plan A, B, C, and D. We also conduct a SWOT analysis of the need to enhance cycling safety. By comparison, we believe that Plan A and Plan B is more suitable for this project. It means line the bike paths and paint them green, put some speed bumps and warning signs at intersection and steep slopes is useful. Okay, that's all. Thank you for listening.
Hi there, we have did some research on bus, taxi and bicycle in Glasgow, and now we have some ideas on how to improve them. Firstly, I'm going to talk about the improvement for buses. We consider that using low emission buses instead of combustion buses is a good measure to help us building a green city with less carbon emission and contribute to achieving the target of zero emission of Glasgow. From the economic aspect, low-emission buses have much more lower operational costs than of the combustion bus. However, some weaknesses like high purchasing price, long charging time, and plan for stages in replacing all the bus to electric ones should be considered. But we have found some solution to address this problem, using the fast charging station and refitting it with hybrid electric vehicles. Then, implementing electric taxis is the way to improve the current taxis. But there are many challenges we may face when the electric taxis are used. For example, many of the charging stations are built with a lot of expenses, and limited battery capacities leads to limited driving range, and the location of chargers should be convenient. To solve these problems, additional battery packs can be installed, or using fast charging ports in charging stations. And developing public EV charging network is vital, with the help of taxi drivers easily finding charging ports. Wireless charging for vehicles is still developing, but the wireless charging installed on a taxi rank, taxi drivers can charge their car every time when they parked on them, which efficiently solves the problem of the long time charging. For the bicycle in Glasgow, the further optimization of next bike is to use the ability to convert kinetic energy into electrical energy. In this way, we can generate electricity when people are riding the bicycle. However, the actual energy generated might be little, so we propose low energy consumption LED street lamp, which can be lit by the energy stored in the bicycle. The bicycle riders can be offered a discount to those who ride a certain distance or generate over a certain amount of energy. The more people ride means the more energy is generated. This can spread the message for the green transport.
Hello, my name is Noé Fernandez and we are the Team 28. Our proposal to create a rail link between Glasgow Airport and Glasgow City Centre is of paramount importance for the economy and for the people transportation needs, who currently are deprived from mass transportation and options are reduced to the use of buses and taxis, which still rely on fossil fuels and depend on the traffic constraints. This options appraisal study will focus on the technological choices available to reduce carbon emissions and provide a fast, safe, and reliable transport system. So let's get started. So this is our options appraisal presentation. Here we have our three options. The first one is driverless light metro. The second one is electric multiple unit. And the third one is light rail transit. The three of them that are zero emissions, energy efficient, and electric. I have here 5 key criteria, which are essential in order to choose the right option. The first one is environmental, which involves reducing the direct and indirect impacts in the environment, such as reducing noise, atmospheric pollution, impact in wildlife, etc. Safety, which is concerned with reducing the loss of life, injuries, and damage to property resulting from transport incidents and crime. Economy, which is concerned with improving economy efficiency for consumers, business users, and providers of transport. Accessibility, which is concerned with the ability with which people can reach different locations and facilities by different modes. And lastly, integration, which is the potential for the development to influence interaction among all transport modes, motorized and non-motorized. So I'm using the rank criteria analysis. Firstly, I discussed the advantages and disadvantages for each of the systems. And then I assigned numbers for each of the key criteria. For the first option, I got a total of 18 points. For the second option, I got a total of 15 points. And for the third option, I got a total of 17 points. So the option that ranked highest was the first option, driverless light metro, with a total of 18 points. Thank you.
Our group focus on the rail in Glasgow. We have decided to link Glasgow Central Station with Queen's Glasgow Station in order to accommodate improved transport and economic development. We came up with three solutions: a tunnel, a pedestrian bridge, and a shuttle bus. Here is the SWT analysis of the existing transfer matrices between Queen Street Station and Central Station. The next part is about ranked criteria analysis. Table 1 shows the criteria which affect the project and the weight of each criteria. Table 2 shows the score of each opinion. The score is 1 to 10. 1 means poor and 10 means perfect. From table 1 and 2, the total score of each opinion can be easily calculated. The result is shown in the table 3. Next part is PST analysis of existing transfer matrices between Queen Street Station and Central Station. The last part is about cost-benefit analysis. According to the cost of London electronic buses, the cost of each bus is 340,000. The estimates for station urge stakes were published by official of rail and road and indicate the station has a total number of 32,915,936 people pass through, which is over double that of Glasgow Queen Street. At the same time, there are 7% of passengers from Glasgow Central Station need to be transferred. The number of Queen Street Station is higher, which is 8%. So it means that there are 3,615,974 passengers need transfer.